Hello guys, this is group number 12 of Division O from VIT Pune. Our group member consists of Rishikesh Potnes, Payal Powar, Sujal Powar, Chinmay Prabhu, Jnaneshwari Pote. We are guided by Professor Aarti Deshpande for subject Computer Organization and Architecture. Our topic for presentation is number system. Number system in computers. The number system simply a system to represent or express numbers. There are various types of number systems, but most commonly used are decimal number systems, binary number systems, octal number systems, and hexadecimal number systems.
Now that we are familiar with the basic notion of a number system, let's look at some of the frequently used number systems. So the first one is decimal number system. Radix or base of this number system is 10. So basically radix or base is the number of distinct digits. So the distinct digits used in the decimal number systems are 0, 1, 2, 3, and so on till 9. So there are 10 distinct digits. So the base is 10. And as we all know, it is commonly used in our day-to-day lives. It's like the first number system we were introduced to. Let's look at an example. So let's take 2048. Each digit in 2048 represents an increasing power of 10. So this is the units place, this is the tens place, this is the hundreds place, and so on. So we can say, in easier terms, we can say that this digit right here represents the number of ones, or 10 raised to zeros, and this number represents the number of tens, or 10 raised to 1. This number right here, this digit right here represents the number of hundreds, or 10 raised to 0, 10 raised to 2s, and so on. The next number system is the binary number system. Binary number system has radix or base as 2, which means that the distinct digits, the number of distinct digits is 2, which are 0 and 1. Binary number system is commonly used in computers or digital systems. So let's look at an example. Like we discussed in decimal number system, here too each digit represents an increasing power of 2. Here 2, as the base is 2. So this first digit right here from the right indicates the number of ones, or 2 raised to power zeros. This number right here represents the number of 2s, or 2 raised to power 1s. This digit right here represents the number of 2 raised to power 2s, or 4, and so on. So it is very logical to ask, why do computers use the binary number system and not the decimal system? So basically, binary has 2 states, 1 or 0. If computers were to use the decimal number system, there would be 10 states instead, like from 0, 1, 2, 3, and till 9. And they would have to work a lot harder to process all these digits simultaneously. Whereas in binary number system, it is a lot easier to compute, and also it takes up less space. To ask, why do computers use the binary number system and not the decimal system? So basically, binary has 2 states, 1 or 0. If computers were to use the decimal number system, there would be 10 states instead, like from 0, 1, 2, 3, and till 9. And they would have to work a lot harder to process all these digits simultaneously. Whereas in binary number system, it is a lot easier to compute, and also it takes up less space.
Decimal to octal conversion. In this method, we convert the decimal number into the octal number system. For this, we follow the given rules. Divide the decimal number with the 8 and write the quotient and the remainder in the different columns. Repeat its division till the quotient will become 0. Next, we can learn it with some example. So, take an example of 645. When we divide 645 with 8, we got the quotient 80 and our remainder will be 5. Then, when we divide 80 by 8, our quotient is 10 and remainder will be 0. Again, when we divide 10 by 8, our quotient is 1 and remainder will become 2. We can't divide the 1 by 8. So here our quotient is 0 and remainder is 1. We write the remainder column in down to up manner like this. So here the conversion of the 645 decimal number to the octal number system is 1205.
Now we are going to see how to convert a decimal number into a binary number. So first take given number here and divide it by a 2. Then write down your quotient here and remainder here. Then divide the previous quotient by 2 and write your quotient and remainder respectively. Then repeat this process until the quotient becomes 0. Then write remainders from top to bottom. The remainders are 1, 1, 0, 0 and 1. So the decimal number 25 is equal to 11001 in binary form. Now we are going to see how to convert a binary number in a decimal format. So take given binary number and count it from right to left. Then take a first digit and multiply it by 2 raised to the power the position of this number. Here the first number is 1 and the position of this number is 6. So we are going to multiply it by 2 raised to the power 6. Repeat this process until the number ends. Then you will get this equation. Solve this equation and you will get 123 as its value. So 111,011 is equal to 123 in a decimal format. The next conversion is converting the decimal number into hexadecimal number. This is repeated division method. In this, we have to divide the dividend with base 16. As we know, the base of decimal number is 2 and hexadecimal number is 16. Moving to the next step, we have to divide the quotient obtained from previous division continuously by 16 till the quotient becomes 0. Here's one example. Here 423 is a decimal number and we are converting this number into hexadecimal number. 423 is divisor and 16 is a divisor. We have created this arrangement. The remainder is written. First 16 is divided to 423. The quotient is, we get the quotient as 26 and remainder 7. Again we divided the 26 by 16 by 1. The remainder we get is 10, but we can't write 10 in hexadecimal number as it is. By the given notation, we return it as A. Again, we divided 1 by 16. Quotient becomes 0 and remainder becomes 1. Here, we know that to write the answer, we get bottom to top arrangement. For the 423, the hexadecimal number is 1A7. The last conversion is hexadecimal to decimal conversion. In this conversion, we given numbering to the hexadecimal number from right to left, starting with 0. Then we multiply the given hexadecimal number with 16 with its numbering in its power. For final answer, we have to sum up all the products. Here is one example. 2A5 is a hexadecimal number and we are converting it into a decimal number. As we said in steps, we have to give numbering to this. Here from right to left, 5 gets 0 numbering, A will get 1 and 2 will get 2. Here the base of hexadecimal number is 16. That's why we are multiplying it by 16. Here we get, after all this setup, we get the equation 60 square into 2 plus 60 to the power 1 into 10 plus 16 to the power 0 into 5. Here the 16th power is that number which is the numbering of the that particular given number. When we calculate this equation, we will get 677. The decimal number of hexadecimal number 2A5 is 677. I hope you enjoyed this video. Thank you.